A surprising discovery has left the scientific world in awe. The James Webb Space Telescope, designed to peer into the farthest reaches of the cosmos, has captured something few ever imagined possible: the detection of what appear to be artificial lights in deep space. These lights were observed near Proxima Centauri b, an exoplanet located just over 4 light-years from Earth and long considered one of the most promising candidates for habitability. But this time, it wasn't just the planet's composition or atmosphere that caught attention. It was the strange, rhythmic brightness, flashes of light that seemed too structured, too consistent, to be natural. Scientists initially thought the readings could be a glitch or an unusual reflection. However, the telescope's instruments, known for their precision, continued to confirm the same pattern: distinct points of light on the dark side of the planet, resembling the glow of city lights as seen from orbit. This phenomenon sparked immediate debate. What kind of natural process could produce such regular illumination? And if it's not natural, then what are we really looking at? For decades, humanity has gazed into the universe with one persistent question: are we alone? Every flicker of a distant star, every shift in a planet's atmosphere, has been studied for signs that life may exist beyond our world. Yet, the discovery on Proxima b may be the most compelling clue yet. The possibility that an alien civilization might be using artificial lighting, similar to the way humans illuminate cities at night, has left astronomers both cautious and exhilarated. Proxima Centauri b orbits within its star's habitable zone, a region where temperatures could, under the right conditions, support liquid water. But it's not without its mysteries. The planet is tidally locked, meaning one side always faces its sun while the other remains in eternal darkness. That dark side, scientists believe, is where these strange lights are emerging. It's not just the glow itself that's puzzling, but the consistency and repetition, characteristics rarely seen in natural cosmic phenomena. These aren't lightning storms or volcanic activity. They resemble something far more deliberate. Astronomers like David Kipping from Columbia University have emphasized that Proxima b's thermal readings are unlike anything recorded from similar exoplanets. While typical rocky planets absorb stellar light and re-emit it as heat, Proxima b appears to give off infrared signatures that diverge from expected patterns. And that anomaly has allowed it to stand out in the data collected by the James Webb Space Telescope. Because JWST is uniquely sensitive to infrared wavelengths, it's been able to isolate and amplify the unusual patterns, confirming that they are localized and consistent with artificial sources. The implications are staggering. If the lights are truly artificial, then it suggests the presence of an intelligent civilization, possibly one that uses similar technologies to our own. It raises new questions about the timeline of such a civilization's development. How long have those lights been shining? Did they only recently appear, or have they been glowing in the darkness for centuries, waiting for our instruments to become advanced enough to detect them? One of the key advantages of the James Webb Space Telescope is its ability to operate within incredibly narrow frequency bands, making it capable of detecting even the faintest signals amidst the vast cosmic background. This capability is exactly what made the detection of these so-called urban lights possible. Unlike stars that flood the universe with light across wide ranges of wavelengths, artificial illumination, if it exists, tends to emit in narrow, targeted bands. This makes it stand out, provided you have the tools to recognize it. JWST does. What makes the case even more intriguing is how these signals correlate with Proxima b's surface features and potential technology. Scientists have theorized that, if a civilization existed there, it might rely heavily on energy harvesting from the planet's perpetual daylight side, where solar panels could convert stellar energy. The night side, meanwhile, would be an ideal location for cities, bathed in artificial illumination rather than natural sunlight. That concept, once just science fiction, now suddenly seems plausible. And now, with this new data, the boundaries of what we consider possible have shifted again. The lights on Proxima b are more than just anomalies. They are a message, whether intentional or not, that we are not the only ones capable of lighting the dark. While Proxima Centauri b's night side remains locked in cold and darkness, its day side is bathed in constant light. This extreme temperature contrast, influenced by the planet's atmospheric composition, presents an intriguing puzzle for astronomers. The James Webb Space Telescope, with its advanced infrared sensitivity, is well equipped to analyze these thermal emissions, providing valuable data about the planet's atmosphere and its potential for supporting life. Due to its orbital position relative to Earth, the JWST can observe both the daylight and night cycles of Proxima b during its 11.2 Earth-day rotation. This continuous observation window is critical for the next phase of study, analyzing the planet's atmospheric chemistry. Scientists are particularly focused on detecting gases like oxygen, water vapor, and methane, key biosignatures that could indicate the presence of life. The discovery of any of these elements would be a major milestone. Oxygen, in particular, is considered one of the strongest indicators of biological activity. However, detecting it poses significant challenges. The process involves capturing and analyzing faint light rays that pass through the planet's atmosphere, a task that requires immense precision. While the JWST excels at identifying variations in water vapor, carbon dioxide, and methane, its capacity to detect oxygen is more limited. Still, researchers remain hopeful, especially as the telescope can also identify ozone, a secondary indicator that may hint at biological processes. It's important to recognize that despite its advanced capabilities, the James Webb Space Telescope can only observe a select number of nearby exoplanets. Its reach, though impressive, is not infinite. For this reason, astronomers are also preparing for the arrival of next-generation ground-based observatories, such as the Extremely Large Telescope, expected to become operational in 2028. With its enormous mirror and cutting-edge instruments, it will provide an even more detailed look at exoplanetary atmospheres, expanding our search for life beyond Earth. The excitement surrounding this field is growing rapidly. Scientists are already looking ahead to future space telescopes that will be equipped to block the blinding light from host stars, allowing them to focus on the faint reflections bouncing off the exoplanets themselves. However, with this level of sensitivity comes a new challenge: distinguishing between gases that are generated by living organisms and those that are the result of natural geological activity. Despite these hurdles, progress continues. The James Webb Space Telescope represents a monumental step forward in our understanding of planetary systems beyond our own. It has opened a new window into the cosmos, bringing us closer than ever to answering one of the most profound questions in human history. Even after decades of searching every corner of the sky, no planet has yet provided definitive proof of life. But each new observation, each anomaly, and each detection of possible biosignatures brings us closer. The dream of finding another living world persists. The question remains: are we truly alone in the universe? If you enjoyed this journey into the unknown, don't forget to like and subscribe for more stories that challenge the boundaries of science and imagination. Thanks for watching, and until next time, keep